Hello class. In the last video we went over the how we name ionic substances. We did the monatomic cations, polyatomic cations, we did monatomic anions, and then we did polyatomic anions, the ones that don't have oxygen in them, and among those that have oxygen in them, we did only the non-halogenated ones. So today we get to do that last part, which is the halogenated polyoxy anions. And after this, we should be done with learning naming ionic substances, pretty much. Okay, so let's get to it. Oxygenated polyatomic anions that are halogenated. Again, remember the halogens? They are elements of group 17. All right. Now, in order to name these ionic substances, it's actually pretty easy and straightforward. Let's go. Let's see. Number one, regarding the charges, they all have the same charge, -1, which is a huge help. Remember, if you have been paying attention, you know that the polyatomic anions can have charges of -1, -2, -3. You know, so here they all have the only -1, which is nice. So you don't have to worry about the charge. You just have to worry about the names and the formulas. Now, they also come in only 4 categories: the ones with 1 oxygen, 2 oxygens, 3 oxygens, and 4 oxygens. Okay, but again, remember, all of them have one negative charge. Now let's start with the ones with 4 oxygen atoms. In order to name these, here is how we do it. We use the prefix per, and then we use the root of the non-halogenated, of the non-oxygen element. In this case, guess what? It's going to be the halogen. And we add the suffix ate. Let's hit an example right away to clarify this. ClO4, again, we use per, and then the non-oxygen element in this case is going to be a halogen, as we said. So, and it is chlorine in the first example here, this example here. So chlor would be, let's say, the root of the name of the name of the elements. The name of the element is chlorine, and then we add the suffix ate. So perchlorate. ClO4 minus is called perchlorate. And we use the same logic with FO4 minus, so perfluorate, perfluorate. Likewise, BrO4 minus, perbromate. Pretty easy, huh? All right, let's move on to the ones with the 3 oxygens. Here's how we name them: root plus ATE. Again, root is for the halogens, the name of the halogen. So ClO3 minus is chlorate, FO3 minus fluorate, BrO3 1 minus is bromate. Pretty easy stuff. Moving on to 2 oxygen atoms. Now we are getting to the, let's say, second half of the number of oxygens, because we have 4 oxygens. So the top half would be 3 and 4, and the bottom half of the number of oxygens would be 1 and 2. Why am I saying this? Well, I'm saying this because now the suffix, which is the last particle in the name, is going to change from ATE to ITE. Let me repeat this. For 3 and 4 oxygens, the name ends with ATE. For 1 and 2 oxygens, the name ends with ITE. So for 2 oxygens, it's just root plus ITE. Here are the examples. And for only 1 oxygen, it's hypo plus root plus ITE. Again, because the 2 end with ITE, so that's similar, and then root, this is similar, we needed to distinguish them. Because of that, we use hypo. Just like here, when we had 3 and 4 oxygens, they both ended with ATE, and then they had this root, so we had to distinguish them by using per for the ones with 4 oxygens. So here, when we have only 1 oxygen atom, we use hypo, which means lacking or low, plus root plus ITE. And here are examples. ClO4 minus is hypochlorite, FO minus hypochlorite, etc. Okay, so this is pretty simple, I think. Let's hit a learning check. Well, I guess before the learning check, let's summarize all this. So again, this is the overview that I gave you at the beginning of the previous video. I just wanted to add one little piece of advice. So if you are to name something, I think if you were to ask yourself these 4 questions in this order, I think that should make it much easier for you. That would make it very easy for you. So number 1, you should ask yourself, okay, what am I naming here? Is this a cation or an anion? Okay, and then is it monatomic or polyatomic? And then is it oxygenated or is it halogenated? If you ask yourself these questions in this order, it will make it a lot easier. And I'll put this in an example so that you can see how it works. Now, let's use this example here. So if I were to break this into two particles, a cation and an anion, hopefully you can see that the cation will be NH4 plus and the anion would be ClO2 minus. Now I need to name the cation first and then name the anion. So let's go ahead and name the cation. So we said first we have to ask ourselves, is it a cation or an anion? It's a cation, okay. Is it monatomic or polyatomic? It's a polyatomic, and we learned that there are only two polyatomic cations that we need to know, ammonium and hydronium. So this is ammonium, okay. So that problem is solved so far. The first half is solved. The second half, ClO2 1 minus. Is it a cation or an anion? It's an anion. Okay, is it monatomic or polyatomic? It's polyatomic. Is it halogenated or not? It is is it oxygenated or not? It is oxygenated. Okay, is it halogenated or not? It is halogenated. Okay, so this is a halogenated polyoxyanion. I need to remember the rules. There are four categories: the ones with 4 oxygens, the ones with 3, 2, or 1. This one has 2 oxygens, so I know that it has to end with ITE. Okay, and also it's the one with 2 oxygens, so it won't have hypo because hypo is for the 1 oxygen. So this would be chlorite. So the name of this should be ammonium chlorite, ITE, ammonium chlorite. Ammonium chlorite. So that's how we name this. There you go, there's the answer. Do you think you can give us the formula for this? And you can check the answer also just by looking back at the PowerPoint. So this is the end of this video. If you wanted to do the whole learning check, just refer back to the PowerPoint file which you have available to you on Al-Khazne, and have fun with it. All right, this is the end of this video. See you in class.